Intermediate Algebra for Statistics, Linear Inequalities and Systems of Linear Inequalities, Part 2. Lesson Objectives: Graph a linear inequality in two variables. Solve a system of linear inequalities in two variables. We'll begin with an example. Sketch the graph of negative 2x minus 3y is greater than 6. Solution: we first want to take negative 2x minus 3y greater than 6 and solve for y. This way it will be in y equals mx plus b form. So our first step is to add 2x to both sides. The next step is we need to divide by negative 3, and if you recall, if you divide by a negative number, you have to flip the inequality sign. So we have y is less than negative 2/3 x minus 2. So our slope is going to be a negative 2/3. Our y-intercept is negative 2. So here's the graph. Y-intercept's negative 2. And if we rise positive 2 and run a negative 3, negative 1, negative 2, negative 3, we have our line. Now this is a dotted line is because we are using a strict inequality, and because it's a less than, we are shading in the area below the line. Now there is a way we can verify the answer. If we pick a point in the shaded region and substitute that point back into the inequality, we should get a true statement. I'm going to use the point negative 3, negative 1. X is negative 3, y is a negative 1. I'm going to substitute this back into the original inequality. So we have negative 2 times negative 3 minus 3 times negative 1. Is that greater than 6? Well, now we multiply and multiply, then subtract. So we're left with 9 is greater than 6. Now that's a true statement. So that means that that point, negative 3, negative 1, is a solution to that inequality. If we pick a point in the non-shaded region, we should get a false statement. So I'm going to pick the point negative 3, 1. So x is negative 3, y is 1 for my point. Plug these back into the original inequality. We have negative 2 times negative 3 minus 3 times 1. We multiply here, we get 6 minus 3 times 1, which is 3. So we have 3 is greater than 6. This is a false statement. So we have verified that this is not a solution and it should not be in the solution set. Lesson objective. Definition. We say that an ordered pair A, B is a solution of a system of inequalities in two variables if it satisfies all the inequalities in the system. The solution set of a system is the set of all solutions of the system. We solve a system by finding its solution set. So the process. We can find the solution set of a system of inequalities in two variables by locating the intersection of the graphs of all the inequalities. So let's look at an example. Example 8. Solve the system y is greater than or equal to negative 2x plus 1. Y is less than 1/2 x minus 3. So solution, we first want to graph y equals negative 2x plus 1 and then color in the area above the line. On the next slide this will be a blue region, and then we want to graph y equals 1/2 x minus 3, change that to a dotted line, and then color in the area below the line because it's a less than, and this will be the red region in the next slide. The graph of the solution set of the system is the intersection of the two graphs of the inequalities. So we are looking at the area that is overlapped. That will be the solution set. So here we have the graph. Here's our first inequality. It's greater than, it's above the line. And here's our second graph. It had a strict inequality, so now we have a dotted line, and it was a less than, so it's all points below the line. So the solution set is the part of the graph that is overlapped twice in this section. So any point in this purple section is a solution. and this shaded region is the solution set. Let's verify. I'm going to pick a point in the purple region. I'm going to use 3, -3. I have to substitute this point in each inequality. So for the first one, y is a -3, x is a +3. So we have -3 is greater than or equal to -2 times 3 plus 1. Let's see if that's a true statement. We multiply and then we add. This becomes -5. So -3 is greater than or equal to -5. That is true. -3 is closer to 0 than -5. Therefore it's bigger. Using the second inequality, we have -3 is less than 1/2 times 3 minus 3. 1/2 times 3 is 1.5. 1.5 minus 3 is a -1.5. So we are left with -3 is less than -1.5. And this is true because -1.5 is closer to 0 than -3. Therefore it's bigger. We have verified the answer. Using a graphing calculator, we hit the y equals, type in -2x plus 1 and y1, change it to a greater than, and y2 we type in 1/2 x minus 3, we change it to a less than, and then we hit graph, and the area that's shaded in twice is the solution set. Example 9. Solve this system. Y is less than or equal to 2x plus 1. Y is greater than -1/3 x plus 2. So for the first equation, we have the y-intercept being a +1, and our slope is 2, up 2 over 1. We have our line. Now this is a solid line is because this is a less than or equal to. For the other line, it's going to be a dotted line because this is a strict inequality. It's not an equal to. The y-intercept is a +2, and then our slope is a -1. We go down 1, and then we go to the right 3. Connect to our line. This inequality is below the line. This inequality is above the line, and this is the region that is intersected. I'm going to verify this by using this point. X is 4, y is 2. So plugging these values into the first equation, is 2 less than or equal to 2 times 4 plus 1. So that becomes, is 2 less than or equal to 9? And the answer is yes. So it's verified for the first inequality. For the second, plugging these values in, we have 4 is greater than -1/3 times 2 plus 3, which becomes, is 4 greater than 1 1/3? And the answer is yes. So this is a solution to this system. Let's do another example. Example 10. Solve this system. Now our first step here is we have to take the second inequality and solve for y. So I have to subtract 2x to both sides. I'm left with -3y is greater than or equal to -2x plus 9. Dividing by -3, which means I'd have to flip the inequality sign. And we have y is less than or equal to 2/3 x minus 3. So here we have the graph. I picked a point in the solution set to verify. X is 6 and y is -1. So for the first inequality, is -1 less than -2/3 times 6 plus 4? Well, -2/3 times 6 is a -12 divided by 3, which is a -4. -4 plus 4 is 0, so -1 is less than 0. That is true. For the second inequality, we have 2 times 6 minus 3 times -1. Is that greater than or equal to 9? 2 times 6 is 12, minus 3 times -1 becomes minus a -3, which becomes +3, and we have 15 is greater than or equal to 9. This is a true statement. We have verified the solution. Let's do our last example for this video. Example 11. Graph the solution set of the system. Here we have 4 inequalities, solution. On the next slide, we will use arrows to indicate the graphs of each of the four inequalities. So for the first one, y is greater than or equal to 2x minus 3. That's all the points above this blue line. The next inequality, y is less than or equal to negative x plus 5. So since it's a less than, that's the area below the red line. So this graph is the vertical line, and since it's greater than 0, it's all values in this direction. And last, the green line, y is greater than or equal to 0. That is a horizontal line. Greater than means points above the line, and we see this region here is the solution set to that system. So any order pair in this region is a solution to the system, and it will make each of these inequalities true. Thanks for watching.